everyone, I'm Mart Zendik Y. Santos, and the focus of my computer engineering innovation is to tackle a major global health challenge, which is access to safe drinking water in economically vulnerable communities. The problem is clear. Millions, including people here in the Philippines, rely on easily contaminated sources like rivers and unprotected wells. This leads to massive outbreaks of preventable waterborne diseases such as typhoid and cholera. The Department of Health reports over 770,000 cases of these illnesses annually, causing immense suffering and economic strain on families. My solution is a simple, affordable, and of course, easy to use turbidity water quality sensor built on the Arduino platform. It acts as an instant screening tool, telling users immediately if their water is safe to drink or dangerously contaminated. My innovation centers on measuring turbidity, which is simply the measure of how cloudy the water is. Cloudiness is a strong warning sign because the tiny particles that make water murky often hide and carry harmful germs. If the cloudiness is high, the risk of disease is also high. The system itself is an embedded system composed of just a few key components. Well, number one is the turbidity sensor module. The turbidity sensor module, or the input, shines a light through the water and measures how much light is scattered by the particles. The second one is the Arduino microcontroller, or the brain. Reads that signal, processes it, and controls the output. And the last one is the 16 by 2 LCD display and the RGB LED, or the output. It gives the user the immediate safety warning, and this design avoids complex network setup and is purely focused on local real-time decision making it highly effective where infrastructure is lacking. Now let's trace the flow of information. This is where the computer engineering principles comes in. Number one is sensing. The turbidity sensor sends an analog voltage signal to the Arduino's analog pin A0. The Arduino converts this into a digital number. Number two is processing. The Arduino then runs the code, and we use a simple map function to take that raw number and convert it into a standardized score between 0 and 100, where 100 is extremely dirty. Number 3 is the logic and output. We use simple if-then conditions to decide the safety level. If the score is below 20, the LED turns green and the LCD stays clear. If the score is above 50, the LED immediately turns red and the LCD screams 30. This is the critical alert. For communication, we use two reliable output protocols, I2C for the detailed text data on the LCD, and direct digital I/O, or GPIO, for the instant color warning on the LED. The most significant impact of this innovation is its power to directly mitigate public health crises by providing a simple, objective warning against potentially contaminated sources. We empower families to make safer choices, which directly leads to a reduction in waterborne illnesses. Fewer sick days means children attend school, adults stay productive, and community health improves overall. This project demonstrates how small, low-cost, embedded systems can deliver massive real-world benefits where they are needed the most.